Hello, good afternoon. As usual, let's start by checking if the audio is working fine for every one of you. So, from what I see here, audio is going through. So, if you guys could confirm that you guys can hear me fine, so then we can get going. If Juan could confirm that the audio is fine, it would be nice. Or anybody from the chat. If nobody confirms, I will just keep going. It's a little low. Okay, let me check. Maybe it's the position of the mic here. Let me check the volume here. Yeah, this is a new headset, so I haven't tried it before. So perhaps that's how it is. It's on max volume here, and from the line level here, it looks like it's okay. Let me see if I can add a little bit of gain. Okay, yeah, it's all good. Let's start. Okay. So again, good afternoon. Um, so most of this video is going to be about the new Quantum 3.0.1 and most importantly, a couple of one new thing that it comes with the SDK, but also something that is already also valid in 3.0, but we haven't explored in detail in any video, so we're going to show a bit about that as well. But before we start with that, I'd like to share some news, general news about Photon, and in particular about Fusion, and just to get it registered here. So let's talk about this here for a while. So we're working hard here to get a new major Fusion released. We're calling it Fusion 2.1. So it comes with a lot of quality of life improvements and of course bug fixes and all that. But I would like to highlight a few of the important new things coming with it. So for on the left here we have stuff that it's valid both in client server modes and also shared mode. So due to the incredible demand on this, so we're actually unleashing RPCs to have any sized parameters that developers want. It's still, of course, not designed to do state transfer, but if you try to do it, it's not going to block you from doing it, right? So the idea here is that you can have bigger parameters like byte arrays on RPCs, and it would not block you from doing that. Not only that, it would also not mess with the general state transfer. It's going to work. So now RPCs are going to be done on top of the reliable streaming API in a separate channel, so it does not affect the general network properties. So this is going to come in 2.1. So essentially, no breaking changes, and if you add a lot of data to RPCs, it's not going to block you from doing that. You can do. I'm going to talk a little bit more in detail about forward physics soon, but the idea here is that we're modifying the included network transform monobehavior in Fusion to by default do physics prediction for you. That by default handle physics. The idea is that if you drag and drop a network transform on a new project and you also drag and drop a rigid body in that network object, you would have predicted physics on the other side. So if it's client server mode, you will have predicted physics on clients, and if it's shared mode, you will have predicted physics on the proxy side. And it's a lightweight prediction that actually scales really well. It's inspired by the way, a little bit by the way Unreal does physics prediction, although this has slightly more accurate results due to the fact that we have tick-based information for that. And of course, you can still fully disable this if you just want to use. I mean, if you have just network transform without rigid body, it's a regular network transform. If you want to disable this even with a rigid body, you can. But of course, if you drag and drop the network rigid body behavior from the physics add-on replacing NT, this would not apply. But the idea is that you would have a very interesting default. I'm going to show a little bit, a few images on how this works. We'll also develop a lot of interesting little text samples to explain each feature and so on. So this was a request that we got from discussions on Discord. So we're going to work a lot on those. But there are some specific stuff that's going to come in shared mode in particular. So before I talk about this, let me take a look at the chat here if we have questions about this. About the turn-based game, it depends. It really depends on what is the gameplay that happens in the turns. So if we're doing a turn-based game like a golf game, which is also turn-based, we have an interesting quantum sample for that. I will do it in quantum. If it's a card-based game, it's kind of challenging to do in either. So I would definitely not do in quantum. And if it is in Fusion, if it's a co-op kind of game, you could do shared mode Fusion. But if it's a more competitive kind of game, neither quantum or Fusion default way would be good for that. But perhaps with this thing I'm going to talk about called server plugins, it could be an interesting idea to do shared mode. It would be cost effective and it could have safety in it, so it might be an interesting. It really depends on the actual gameplay. Just the fact that it's turn-based doesn't say much. Oh, so thanks for joining, Giga Busy. Yeah, we are discussing about terrain trees on quantum, right? So yeah, thanks for joining. Thanks for joining, everyone. So everybody who asked as well, and yeah, let's move on here. So we have some specific new things that we're adding to shared mode Fusion with this new Fusion 2.1 that's coming. Some improvements have been done in state authority change. State authority change request. So when you request to become a state authority of a certain object, that is now locally predicted, and it works with a very reliable transactional model in that if it doesn't work, you receive a callback and it doesn't break your stuff. And if it does work, your local prediction was already in place, so you have a very seamless data flow and it doesn't glitch or anything like that. So this is coming. I think the same happens. I mean, destructing an object is also transactional. You can get a callback if it was, or if you also actually if you request you change the state authority and then the object got destroyed in the middle, that's also handled seamlessly. So there are a few improvements on that. But the biggie here is the fact that we're finally making available server plugins for shared mode. So people who want to do, let's say, cheat-proof games pretty much are, I mean, competitive games that you really need to go cheat-proof. You either go for Fusion dedicated server or you go for quantum due to determinism. But we always said that we were working on server plugins for Fusion shared mode, which brings both the cost scalability, like the cost effectiveness of Fusion shared mode equivalent to quantum, together with the ability to have code running on the server, aware of the data in the network objects, and also being able to validate that and spawn objects and control them from server code. So this is finally coming. Of course, because we're talking about custom server code, this is the stuff that you would only run on an enterprise setup for now. But we're going to start making this available, I think, early next year for Circle customers who are going that route. But there's a long-term plan here involved also with some ideas to have this even for no-enterprise. But I'm not going to dive too much into that. That's very far from. But that's the kind of stuff we're working on. Another important thing, shared mode, we have a dedicated doc let's say category, and it's going to be more split into that. You have very specific to client server, very specific to shared mode, not only docs but some samples and a lot of stuff to make sure the onboarding process is very clear about these different modes. But I'm gonna show some stuff visually here to talk about these two things I highlighted here, forward physics and server plugins in shared mode. But before we move on, let me take a look at the chat here. I'm gonna answer GigaBusy question later because I'm still talking about this fusion news here. As soon as we go into quantum, I'm gonna answer that. Yeah, okay, so I'll answer it after we finish this here. So let's move on here. So this is about what I was talking about, the physics prediction, right? So traditionally, physics prediction in quantum is done with the resimulation approach. So basically, you get in quantum the equivalent of a server snapshot is when you have a confirmed inputs that we simulate forward, let's say the verified physics state, and then we always resimulate forward the full prediction to the current time, and that means resimulating physics, all the steps, all the ticks, all the way to here. That's very accurate. That gives very good physics prediction. But of course, we can only do that in quantum because both our physics engine and the whole engine is designed to be stateless and designed to be easy and cheap to roll back and resimulate. So that the same cannot be said for PhysX, which is a great physics engine, but it's not designed for this. So you could still do this, and this is what we do on the full prediction mode for the physics add-on in Fusion, but it only works if you have just a bunch of rigid bodies you are resetting. If you have a lot of these things, the performance is really very easily goes into unacceptable territory. And this is due to the fact that the physics engine is not designed for this, in this case PhysX. So Fusion is fully capable of doing full prediction, and PhysX is a great physics engine. It's just that PhysX is not designed for that, for rolling back and resimulating all the time. But we took a bit of inspiration for the way Unreal does, let's say, heuristic style physics simulation, and we're adding this to Fusion 2.1. And this is the image on the right it shows a bit like how it is. So the data we get from the server in case of Fusion, or in shared mode, the data you got from the authority of the object in shared mode, if you're a proxy, is used as a valid snapshot. But what we do is we can compute what could be the current state of it within a heuristic based on what we received, velocities, dragging, and possible collisions, a few other things. So we kind of like project it forward in time without actually resimulating all the steps. There are a couple of modes. We can do this either by applying a force or by specifically teleporting the object. And then we can let PhysX do only one step, which is the normal way Unity works, either on its own physics fixed step, or when Fusion is ticking the physics engine. In either case, this basically does one step, and with the heuristic correction, surprisingly, this gives very, very, very good results for most use cases. So if you're doing, let's say, a survivor kind of game, or the traditional TPS, FPS kind of stuff, or even maybe a shared mode, moving around things that you can sometimes push a few objects and so on. This kind of like just works. It really feels like a local enough physics. The only case that this really does not, of course, solve as really well is if you're doing a sports game where you really need a super accurate prediction of all the objects and so on. So in that case, it's still about full resimulation. So it's still recommended to go for quantum and so on. But anyway, this is coming in Fusion 2.1. It will be default on the network transform. You don't have to add anything. You can opt out of it if you want to have the traditional simple network transform and do your own thing however you want. But by default, you will come with this, and it scales well in performance and gives very interesting results that makes the physics feel local and interactive. Next, about server plugins. So, interesting name here, right? So this is a WebGL build. I'm not sharing the link for this yet. So this is it's a bit hidden, but this is an interesting sample that is a shared mode game that is a small, let's say, shard session done in shared mode that runs perfectly fine on WebGL or on PC or in that kind of stuff. And it is shared mode, so it is, let's say, cheatable. It's client authoritative, right? Yes and no. So the sample will be soon available, I think together with 2.1 after some time, but it comes with a twist. So this is also the sample that demonstrates what you can do with server-side plugins. So this sample is being developed together with the server-side code that can actually control NPCs from the server or validate what the player is doing, if he's moving too fast, if he says he hits something on certain NPC, the server can validate all that. Or if he says, I didn't take damage when the NPC hit me or whatever, it can also be either run on the server or validated from the server. There's a lot of stuff that you can do to run on the server and still scale in terms of costs with a CCU only, let's say, pricing. You don't have to handle dedicated servers, like orchestrating dedicated engine instances like in client server mode with dedicated servers, and gets kind of like the best of both worlds. So this sample is going to be the target example. We always try to eat our own dog food in trying to, whenever we develop one of these massive new features, we try to do it also by trying to develop a little game that tests what we're trying to do to see if it makes sense to actually do that. So that's what's coming with soon with Fusion 2.1 for people who want to do server-side plugins, custom plugins to run on our own cloud. But the sample itself, the gameplay, is going to be available to everyone, as far as I know, at least. But to finish here on the news stuff, there's something available now, also on Fusion Land, which is the new Pirate Adventure sample, which is another shared mode sample. And this is available starting now. I think it was deployed a few moments ago, just before the stream. So you guys can go ahead. And as part of a way we're kind of like doing a revamp on the docs and all that, there's kind of like a new look and feel for how we organize the structure of these docs, and we're trying to embed WebGL builds whenever we can. So whatever is the sample that we have, we will try to get here it playable. So this is actually a WebGL build of the game. I can just play it here, and I could just play the game. And you can do this now. Just go on the website, check this out. You can play together online this, and we're doing this for a lot of the samples. We actually have a page on itch.io with a lot of the samples, and this one is also there. But yeah, this is a new sample. It's available now. There are a few others being built, but I wanted to show this thing here. So let me take a look. I'm going to also answer Dark Sides of the Day question as soon as we finish this one here. So, okay, so that's what I wanted to talk about Fusion. Let's stop there for now, and let's then move on to Quantum, and then I will be able to pick up the questions. So I wanted to start here from, as the title says, we recently released new update 3.0.1. There is a lot of stuff here on the release notes. I'm not going to go over these in detail. It's really about it's a non-breaking update. You just import it on top of your existing 3.0 project. Should be a clean update. But there are two topics I want to cover, which is in the title, which is first, there is the view framework that I never dived into too many details to explain how it works, and I'm going to do it today. And also, there's a new thing called the input demos, the demo inputs, which is an interesting pattern that we found while developing stuff that I always share with a lot of customers in Circle, and we decided just to make it a package inside the SDK. We're going to explore that a little bit today as well. But first, I'm going to pick up the questions here. So use Quantum Snapshot as a save state to make easy save load system. So on the technical side, busy, that is possible. So you can technically just serialize verified frame at the end of a game in Quantum locally, store it anywhere you want, and you could technically load that when restarting a game. And if you do that carefully by loading it on your local game, not local, but on an online game, but you start the session when it's not joinable, the room is not joinable by others, so you make sure to start Quantum locally, and then you let people late join receiving your snapshot. Or if everybody has access to the same snapshot, they could also preload that one at the beginning, even if they're joining from the start. So these would work. But there is a reason why we don't recommend this, and that it's not really a solution. The problem with it is that it only works with one specific version of the game. So whenever you add, let's say you add a new property to the game state, the serialized state does not work anymore. You cannot load it anymore. Because the serialization Quantum does is exclusively for late joining snapshots, very quick, very fast and efficient on top of the existing game state data you have with all the QTNs and the frame you have. Whenever you have a new version and you change a property, you add a property, that doesn't work anymore because this is supposed to do for runtime for people on the same version. So it is not designed to solve what we're talking about. Long-term persistence is always something you handle with a bespoke type of code. You have properties that change name, you have new addition to properties. So it's not so simple. And normally you do not need to store the whole game state. You just need to store relevant stuff to respawn. One thing you could do in that sense is more like you store at the end of the game the progress, and you send as part of either runtime player or runtime config a very compressed version of what you need to, let's say, continue from where you were, kind of like the very compact save state, not a full frame. But yeah, all you handle in a more bespoke way. But that's why we don't recommend that at all, because it's not designed for that, and it would not cover the actual problem with long-term persistence, which is what you need. So let me talk about DarkSide's question on Quantum Unreal. Yes, Quantum Unreal is in active development. Actually, we released yesterday a new early access preview version. So yesterday, preview 10 was released internally. I actually have access to it, though. Well, I would have to type it in here, but I can. Quantum Unreal. I think I can just do this. Yes. So here it is. So it was actually 2 days ago. It was not yesterday. So here it is. But here is Quantum Unreal SDK build 10. Preview build 10. This is the one I'm talking about. So yeah, we just released this yesterday. So what does it do? It fixes a bunch of stuff that we found together with people who are actually using this. And we now we support, and actually we made it the minimum in Unreal version 5.4.4. So we support 5.4.4 and up. It's still a preview, so we're still defining which one is going to be the minimum supported version. For now, it's 5.4.4. Yeah, I think there are release notes here saying what is changed. But yeah, it is in active development. There are a few customers actually prototyping with this. This is still Circle exclusive. We don't have any ETA for when this is going to be publicly available or a stable version, but it is in active development. It's being actually used by a few studios. So I'm not going to answer the question about regions and how to check that, because that's a question about matchmaking in real time that you can find. There are a bunch of examples people shared about that in general on Discord, and you can always get like on this matchmaking guide, so you can connect to the different regions and get how many CCUs you have in each one of them. So for example, you try first the region you are at, then you have a list of whitelisted regions you get for your app ID, and you can try to connect to the ones that are closer to that person based on the ping in sequence, and then you lock into the one that have enough CCU. So that's very straightforward to do. Just follow this stuff in the matchmaking guides, and it shall be straightforward to do. So not much to say. It's not really a very, very complex problem. The APIs allow you to query that information. If you're connected to the master server of a region, you know how many CCUs you have. Connect to the next closest one. Do it a couple of times until you get enough. Okay, so thanks for the questions. I hope I helped answering them here. Let's move on to the actual technical topics for today. Okay, so just double checking here. So this is I've shown this before. This is a little sample I've been using, a little prototype I've been using to develop the. Can you guys hear the audio for this? I think so, right? Yeah, it looks like it's going. So yeah, I'm controlling both players. This is a local game running here. I use this to actually develop the KCC, and I'm shown this in GIFs and other screenshots on Discord. But we're gonna use this to understand a little bit how both the view framework works and the demo inputs work. So I'll start with I'll actually start with the demo input stuff. Okay, thanks iPod. Yeah, it's a little bit louder. I'm gonna disable the audio for the stream because we don't have to hear. It's a sample that has all the little juiciness on everything. I enjoyed doing all those little things. So if you pay attention, it has like particles when you jump up, when you land, and also when you jump from walls. There is a squish and stretch for the character. All those little things it makes it feel good. Thanks, Niels. So let's talk. So it's actually just two topics today. So let's start. Let's go straight to the point now. So a lot of people ask and get a bit confused with the input in Quantum, and we always teach you that okay, you go there and you define something like let me make this the font a little bit larger. So you do something like, oh yeah, input, and then you define the quantum input struct with stuff you want to have. So for example, button fire or something like that. And then we instruct you to pull the input from Unity with whatever input framework you have on Unity and use the quantum state machines for that. But people always get confused with a bit more complex stuff, like how do you do aiming with directional stuff? How do you do 3D kind of input for pitch and yaw? Or how can you, and another very interesting question is why can I have multiple input types for different game modes? How can you have that? How can you have on the same quantum game, you make quantum use different inputs types based on the game you're running? So you have the same project, but you want to have different game modes. People are playing a 3D kind of, or a top-down kind of map, or maybe in the same game, you have something like you are moving around with a character and then you get into a car, you want to have a different, even the quantum input structure you would like to be different. So what is the answer for this? How can I have multiple input types for different game modes? The technical answer, if you're asking about the quantum input type, is you can't. You can only have one input type running all the time, and this is the one that once the session is done, it's the one that is going through. Of course, different versions of the game can have different versions of the input struct, but you cannot really have inside the same game multiple different input structs. The quantum input structs cannot be different. So how do you solve this problem? Well, you create multiple input structs. But how if you can't? So here's the trick. Just use C#. So what we're going to do here is, what we actually, I always said people should do is, Quantum's input should always be kind of like a virtual input, that you have just as many buttons as you need, as many directionals as you need, with all kinds of the type of compression you need. And it's kind of like invariant. You just cover everything you need. Notice that the regular input struct is only for runtime controlling something. You can always use commands for complex stuff, and you should use commands. There is no excuse for not using commands now as of Quantum 3 because they are even predicted. So there is no need to complain that commands were not predicted. I'm going to answer that when we see, but it's not. That's a union. It does kind of send both, but it is harmless. The point is that Quantum is data compressed, so if there's nothing on the data, nothing is going to be sent anyway. So it's, but I'm going to get to that. So I'm just using the union approach. That's the Quantum union. I think you are confusing the serialization of input of the struct for the game state transfers with the special serialization we have for inputs that does the data compression. So that's slightly different. But anyway, when I get to show that, I will explain. We're a little bit before that. So I always said, what you do is you create actually a single input mapping that covers everything. And with quantum data compression, that means it will only send what is actually used. But my idea is that you actually never ever use the quantum input struct directly. What you're going to do, so let's roll out. So the input struct equals a complete virtual gamepad or so. It is, I like to use the gamepad because it's the most complete one. Anything, keyboard is just a digital type of gamepad. So if you have the gamepad you can do the same with a keyboard. So gamepad is the more complete one. So I like to think about it input as a gamepad. I mean, a fully fledged with multiple buttons, like a 12 buttons gamepad. So that's the virtual one. So what you do is you create custom structs for each input mode. And you define implicit casts to, from, between these and the main input. So essentially, you will never touch the input struct in Quantum when writing gameplay and when sending input. You're going to touch your special inputs that are specific to the game. And you can change that in runtime because the idea is that on the polling side, you create your own struct. And when you set the quantum input struct, it is cast from yours to quantum. And on the gameplay, you read the quantum casting to the one you, based on the mode you were playing, and you would implicitly cast to yours, and you always use your type, you never use the quantum type. And so what we did on the demo is we just implemented this pattern with 3 different, let's say, input modes that cover, I would say, 99% of the games out there. I haven't yet seen a sample we have that cannot be done with one of these 3 without any modification. That's how we designed them. So let's take a look at how this all works and see how I use it in this particular sample. So the sample doesn't have any more anything related to input directly. What it does is, because it actually copies the input struct into the game state of the component, because it doesn't matter if it's generated by AI or by player, it will use it the same. So I'm using actually this struct here. So which struct is that? Let's take a look at all the DSL generated stuff here. So first, because I think I forgot. Oh, I forgot to add comments to these. And can I do that? No, you cannot do that in KTN. So if I don't make comments, you would of course complain. because this is not valid QTN. I think now it's gonna, yeah, now it's gonna compile. And it didn't change anything. So let's take a look at the actual Quantum demo input. So what happens is if you install Quantum 3.0.1 now, it comes with this Unity package. Just import this Unity package after you have the Quantum installed. You would uncompress to these two things. So there is some simulation stuff and some view stuff. They're both great for you to get started. So simulation stuff has this is what I call the virtual gamepad. So this is the actual Quantum input struct definition. You will never have to touch this. This is just a complete D-pad, then the right buttons, the color or shaped ones on those console controllers, and then you have other digital ones like the two-shoulder digitals and let's say the equivalent of select start. You can also have the analog triggers mapped with a byte. That's very economical. And I created two types based on a union for the thumbsticks. So the left one is always an angle and an encoded magnitude if in use. And the right one can either be the same using bytes, or if you're doing a 3D, it's going to be 16 bits to do pitch yaw instead, because it's for aiming or for, let's say, mouse if you're doing a 3D shooter. But the point is that you never have to look at this. This is all stuff that you will never see in your code. It's pre-mapped. You don't have to look at it, or at least, maybe not you, but maybe your gameplay programmers or Unity programmers never have to see this. What is the meat of it is actually the specific structs that can be used on the different game modes. So let's take a look at the platformer mode input. That is a subset with better named stuff. So the Quantum input for platformer 2D includes left, right, up, down as buttons, not as analogs. It's a design decision. You can do differently. And then 5 different, like jump, dash, fire, alternate fire, and a dedicated use button. So okay, cool. Looks like a nice. So GigaBusy, don't worry about the size. The actual size of those structs is 9 bytes. It's 9 bytes when it uses the. It would be 9 bytes if it was just the small version, and it is actually 11 bytes because it has the larger struct that has 2 higher definition bytes, so it's short. So in total is 11 bytes. But remember, Quantum does delta compression. Don't worry about that. Quantum does not send if data is not used. It doesn't send anything. It sends 0. If it's not, it doesn't send a 0 number. It sends nothing if from one frame to another a portion of the data didn't change. So just don't worry. Bandwidth is never going to be a problem. You will never even see this being a problem. Not even close. Not even close. So this is what matters. This is the struct that will be your input. You're going to think about this. So the polling side, you're going to be converting from Unity inputs to these. This one here, for example, you actually don't set it. It's just going to be more for getting the value. These are the ones that you actually set. Oh no, sorry. You also set this one, because that's for the aim direction for a 2D platformer. So, so how do we convert this struct? So there is here, it comes also with this partial file that is a partial implementation of that struct, the struct that we have here. And it basically we show how we implemented a cast. So from platformer 2D input to the Quantum input. So this is what happens on the polling side. So you actually fill in a platformer input and you set it to Quantum to be sent over the network or for prediction, and it converts it to the Quantum regular, let's say, virtual gamepad inputs with an implicit cast. And basically we map from buttons to buttons, and we encoded the direction with just the angle. We don't have on the platformer, we decided not to do with the magnitude of the encoded, because that saves data. You don't have to send if it's not necessary. And here's the opposite, how it's converted from the Quantum regular input back to the game mode specific struct. So this is just implicit cast. So this is C#. This is not Quantum. This is regular C# code. I also implemented here a getter for, okay, what if you want to have the D-pad digital direction, like the 8 directional, as a vector? It's a getter only that converts from the buttons that are on into a vector normalized if it's diagonal. So just that, super simple. It's just a getter. So with this in place, what you actually use is you have the demo polar that, this is the interesting part, so pay attention here. You don't see the quantum input type here. You only see your game mode specific input here. There is demo platformer input. You set the buttons based on what you got from Unity. And I'm not using this case here. Blueless example actually sets this one here, the aim direction. This demo here doesn't, but you can just fill in here an aim direction based on the mouse and where the character is. That's what Blueless platform shooter does. But the magic is here. So when we set the input that requires a quantum input struct, here the cast is automatically being done. So we actually filled in a demo input platformer 2D struct, but because there is an implicit cast implemented, it converts just fine to, here it is, the writer shows it to us, so it's being automatically cast to input, which is the one that Quantum understands. But the point is, you as a programmer don't have to think about the quantum input, you just think about your mode input. And this can be done differently in runtime. So you can have your input polar send one or the other depending on where is you are inside a car, or if you are outside the car, or the game mode in use. You can even have different style of inputs for different players if you want to think about that, as long as it casts kind of convenient to the one that you use on the simulation, it's fine. But in this case here, we're trying to map from one to the same when it gets to the simulation. So how does it work in the simulation then? On the simulation, let me think here how I do it. So I think I just need to take a look at the, yeah. So what I do here is, maybe all of you are familiar with getting the player input in Quantum, which gives you a pointer to the quantum input struct. So here you just make the cast magic happen as well. So I'm getting that pointer, but I'm interested in the content of it, not a pointer, but the contents of it. I could also make it a pointer. No, a pointer would not work here, but I can make it as the content of it, a copy of that input struct, and I can store it into my mode specific one. Here, the other side of the cast is happening. It's being cast from input into the specific mode input using the code from here, from this one here in this case. So it's actually running this. It gets the quantum input and it copies the data, all the buttons state into the one that you are interested. So from the simulation side of things, you just think about the input, the specific struct for the input mode. Yeah, you can easily cast. This is a C# feature. Just use the features of the language, right? So it is super fast, super quick, and it allows you to have all this flexibility, right? So what is this all about here, this demo input stuff? It basically comes with 3 examples that you can just drag and drop. So this original prototype didn't use this. I did have my manually done input, and then to convert this to this system took less than 5 minutes. I just imported the demo input, deleted my old references to input, converted them to the new specific mode I wanted to use. In this case, the platformer 2D would fit perfectly here. It actually has more data than I need, but I made it compatible with that. And then my polar, I just drag and dropped the demo polling for platformer 2D here. I'm not even changing it. I'm using the demo as it is. And on the simulation, I'm doing this. I'm copying. This is my specific simulation. I get the copy of it here, cast back. I set it into the KCC because the KCC gets that as a demo. Because I made a KCC component have a copy of it here. And then I basically made the code that moves the KCC. So for example, it already had, so process jump would already get the input and check jump was pressed. So then even the names were the same, so it was super easy to make sure it worked. And the code worked the same. I had a very similar set of buttons, so it was very easy to get it working here. And actually, I think I didn't have to change anything here because all the buttons had the right names already. It's just names I always use. So then, yeah, it's all using here the specific struct. And the point is you can have different game modes always using one of these types or the other. Or you can have, even in runtime, switch between them. As long as your simulation and your polling are doing the same on both sides, it will work seamlessly. And a cast is normal, is just, it's not, it's made in, the demo cast we made are even safe to do if you originally, for one tick, you sent one type and on the simulation you try to use it as the other type, it's not breaking. It kind of maps most of the buttons and most of the directions, and the rest is going to be default, just that. But as long as you switch between them in runtime correctly, it's also totally possible to use. So it comes with 3 demos, as I said. So I've shown the 2D platformer. But there is one that's a little bit, it's similar to this, but it is more like for top-down games, doesn't matter if 2D or 3D, which has a move direction that is without I think this one has magnitude as well. I'm not sure. Maybe it's just also without magnitude. But the aim direction here has a magnitude. It actually encodes the size of the vector because you may be aiming with a distance, kind of either with the mouse or with a thumbstick, kind of like a Supercell style Brawl Stars input or League of Legends kind of input. And a bunch of other buttons here. Well, the buttons are the same, but it adds the aim direction and adds the move direction as an analog movement for the top down, and it has the corresponding cast and the corresponding here, and it has the corresponding example polar if you want to use. And last but not least, we also have a demo input for a 3D shooter, and that has a bunch of buttons. It has the same move direction with magnitude. It's normalized 0, 1. And it comes with a pitch-all that you can use as absolute value. So you don't have to send as delta. So this is like, what is the current aiming pitch and yaw of the character. So you can always send this as input. So you can keep on Unity an absolute value as floats, and then just send these 2 angles as FP, but technically it is cast to use those 16-bit ints because have enough resolution and saves a bit of data using that. And they're clamped to the max min values you can do. So the up down, I think it's clamped at plus minus 89, so it doesn't even go 90 degrees because that creates gimbal lock. And the yaw is clamped between minus and plus 180 degrees because it just circulates if you go above. So that is the way the 3D one is done. So you can just check that. We're going to be updating all of the samples to use all this. And I think the first one is blueless, is already. The next deploy of blueless is actually going to come with this new input type fully mapped. But I think asteroids is also using. So on the SDK now, if you get a new one, asteroids actually get already to use this. I think you use the top-down input. But guess what? We anticipated the stream for 3, and I'm already talking too much, and we only have 10 minutes, and I'll have to leave in 10 minutes. So we haven't started to talk about the view framework. So I'm not going to try to rush anything. and I think it's a topic that deserves us to talk to go through the examples. So, okay, so one just said that twin stick shooter is also already using it. So we're mapping all of the samples we have to use this input, these predefined demo inputs, because they're so convenient. But I'm not gonna try to rush talking about the view framework here. We can reschedule to talk about the topic. I really apologize, but I wanted to explain in details what these are as well. But we still have time for a few more questions. So let's see if you guys have a few more. And I can take them and answer here as much as well as I can. And until we get a few questions, I mean, I can at least talk a bit about what the view framework is. So normally when you're doing, so writing the simulation is just half of it. So a game needs to have a presentation. And although Quantum automatically creates entity, I mean, if you have an entity view, it actually moves them around and interpolation. You always have to do something like control animation. You have to do a bunch of stuff on the UI. You have to have a score, stuff like that. So you always have to write Unity scripts to do that. So the view framework is a way to do that with less boilerplate code. That's it in a nutshell. So we came up, we paid attention to the patterns we would always use when we were writing these Unity side scripts to either control stuff that like it's about the character, like these little floating nicknames, or UI like the ammo I have on these rocks. So if you see there's a little rock here on top of me, so controlling this, or the score here on the top. So we learned over time how we always do this. What is the objects we always have to access, like the frame or like the entity ref of the corresponding view we are at, and the game instance or the session instance, or even the entity view updater. And so all these things we kind of try to give a cached reference to them. But we're going to explore this in detail next time because we're out of time. Let me see here what we have as questions here. So how to decide? It's not a stupid question. It's always good this. So question here from GigaBusy again. So how to decide when to use commands versus input? So my rule of thumb is basically the following. Whatever you are doing that is tick by tick direct control of an entity, like I'm moving a character. It's like my move intention on a game that I control my character directly. By directly, I mean I move left, it moves left. I move right, it moves right. Or I shoot, it should shoot. This is buttons or small analog directions like angles and so on. So that is input. That's regular input. Whenever you have something like a decision or something that happens occasionally that needs parameters, so think about, I want to, an interesting example is like reloading or switching weapons. Switching weapons is interesting. I will use the switching weapons as an example. If switching weapons is basically tabbing between the existing weapons, it can be a button, because basically you can use the on was pressed to switch between the different weapon slots you have. But if switching weapons means like pressing 1, 2, 3, 4, 5 to say which weapon you are selecting, you have to send a parameter together with it. So in that case, I would use a command. I would use a command to switch weapon. But the most common cases for commands are like I am at a character, I want to loot something, and I want to say, from this bag of items I want that is in front of me, I want to loot from this entity here. I want to loot items 0, 2, 3 from his bag of items. I don't want all of them. So that is sending a command with a small array or list of the things I wanna actually loot, or initial loadout. I'm here on the store. This is my initial loadout. Or I'm buying ammo for this. I'm buying Kevlar kind of stuff, like Counter-Strike style store. That is, you select stuff, send a command, send a command, send a command for that. So that's command. But even this thing about like flipping weapons, if it is a selectable number, I would use a command for it. Because input is basically immediate intention, like a new direction to move towards that you would keep doing, or jumping, firing, like the mappings show here. Basically what these mappings show are the examples for input. Everything else is a command. If you're doing a click to go game, commands all the way. Every time you click, command. Click, command. So I only have 5 minutes, so let me see the questions. iPods, is it possible to differentiate between it already existed versus spawned? No, not really. No. It doesn't make a difference from the view perspective. It could be also a replay. Remember, it could be a replay that's being spawned and you have to spawn stuff. They all existed, so there is no difference. It's just that, oh, it's this view is being created. It's the same rule of thumb for UI. From onActivate, you have to be able to initialize your view from onActivate. Always be able to initialize from that. And updates can be either polling or events, but always initialize everything you need from onActivate. Also because onActivate is called multiple times for the same view when you're using a pool, which is a recommended thing. And Juan also helped with the question here about the inputs. Thanks, Juan. So, unfortunately, I have to stop for now. And it was totally my failure not to plan. I had to be able to finish this. We go back to View Framework next time, I promise. And I hope this was still useful. And feel free to drop more questions over Discord. We try to answer them as much as we can. So thanks again for joining, and see you guys next time.